Hello everyone and welcome to this video on variables in Python. Variables are one of the most fundamental concepts in programming, and in this video we'll explore what they are, how to use them, and why they are essential for writing Python programs. Whether you are a beginner or looking to strengthen your basics, this video will give you a clear understanding of variable assignment, naming conventions, and Python's dynamic typing. Let's dive in and discover the power of variables in Python. Introduction. A variable in Python is essentially a name location in memory used to store data. Think of it as a container that holds values which can change throughout the execution of a program. Variables play a crucial role in programming by allowing developers to work with dynamic data, making the code more flexible and reusable. When you create a variable, you assign it a name and store a value within it. For example, age 25 assigns the value 25 to the variable age. The variable name acts as a reference to the stored data, enabling you to access and manipulate the value easily. Python variables are highly versatile. They can store different types of data such as numbers, strings, lists, or even objects without needing explicit type declarations. This dynamic nature of variables makes Python an accessible and powerful language for beginners and experienced programmers alike. By understanding variables and how they work, you can write more efficient and maintainable code, making it a fundamental concept to master when learning Python. Declaring variables in Python. In Python, declaring variables is straightforward and doesn't require explicit type declarations. Unlike many other programming languages, a variable is created the moment you assign a value to it using the operator. This makes Python highly dynamic and user friendly, especially for beginners. For instance, you can declare a variable like x10, which stores an integer value. Similarly, y3.14 assigns a floating point number to the variable y, and name Python assigns a string value to the variable name. Python automatically detects the type of data being stored and assigns it to the variable without requiring you to specify it explicitly. This flexibility allows you to focus more on logic and less on rigid syntax. It also means you can reassign a variable to store a value of a different type later in the program, adding to Python's dynamic nature. Understanding this simple yet powerful feature is essential for writing efficient and intuitive Python programs. Dynamic typing in Python. Python is a dynamically typed language, which means the type of a variable is determined at runtime rather than being explicitly declared beforehand. This dynamic nature allows variables in Python to hold values of different types at different points in the program. For example, a variable that initially stores an integer value can later be reassigned to hold a string, float, or any other data type. Consider the example x10. Here, the variable x is assigned an integer value and Python automatically determines its type as int. When you use the type function, it confirms this with the output class int it. If you later assign a string value such as x hello, the type of x dynamically changes to str as shown by the output class str from the type function. This feature makes Python highly flexible and easy to use, as you don't need to worry about declaring variable types explicitly. However, it also requires careful handling to avoid errors, such as using a variable in an operation that isn't compatible with its current type. Understanding dynamic typing is crucial for leveraging Python's flexibility while maintaining clear and error-free code. Variable naming rules. When naming variables in Python, there are specific rules you must follow to ensure your code runs smoothly and remains understandable. These rules help maintain consistency and avoid conflicts with Python's syntax and reserved keywords. Firstly, a variable name must start with either a letter A, Z or a Z or an underscore underscore underscore. For example, underscore var5 is a valid variable name because it starts with an underscore. After the first character, the variable name can include letters, digits 0 to 9, or underscores. For instance, name1 Python is valid because it follows these rules. However, variable names cannot begin with a digit. For example, 2 variable 10 is invalid and will result in a syntax error. Additionally, you cannot use Python's reserved words such as if while or class as variable names, as these words have special meanings in Python. For example, if 20 will cause an error because if is a reserved keyword used for conditional statements. By following these naming rules, you ensure that your variables are properly recognized by Python and your code remains clear and error-free. Adhering to these conventions also helps other developers understand your code more easily, fostering better collaboration and readability. Reassigning variables. In Python, variables are dynamic, meaning you can reassign them to hold new values at any point during program execution. This flexibility allows you to update the value of a variable based on the program's logic or user input. Reassignment is done using the same assignment operator used for the initial assignment. For instance, consider the variable x10. Here, x is initially assigned the value 10. Later, you can update x to hold a new value by performing an operation such as x5. This expression means take the current value of x, add 5 to it, and store the result back in x. When you print the value of x after this reassignment, the output will be 15. Reassigning variables is a fundamental aspect of programming, enabling dynamic updates and calculations. However, it's essential to use meaningful variable names and keep track of their values to maintain clear and error-free code. This practice ensures that your code remains easy to understand and debug, especially in larger programs with multiple assignments. Python provides a convenient feature that allows you to assign values to multiple variables in a single line of code. This feature simplifies variable assignment and makes your code more concise and readable, especially when dealing with multiple variables. For example, consider the statement ABC123. Here, the values 1, 2, and 3 are assigned to the variables A, B, and C respectively in a single line. When you print these variables using print A, B, C, the output will be 1, 2, 3, reflecting the assignments. This approach eliminates the need for multiple lines of code like A1, B2, and C3, making the code cleaner and easier to read. Multiple assignments are particularly useful when you need to initialize several variables at once or work with functions that return multiple values. By leveraging multiple assignments, you can write more efficient and elegant Python programs while maintaining clarity and simplicity in your code. This is one of the many features that make Python a powerful and beginner-friendly programming language. Swapping variables. Swapping the values of two variables is a common task in programming, and Python provides a simple and elegant way to achieve this without the need for a temporary variable. Using Python support for multiple assignments, you can swap variables in a single line of code. For instance, consider the variables a5 and b10. Traditionally, swapping their values would require a temporary variable to hold one of the values during the exchange. However, in Python, you can use the syntax a, b, b, a to directly swap the values. This works because Python evaluates the right-hand side of the assignment b first, creating a tuple of the swapped values. It then unpacks these values into the variables a and b on the left-hand side. After executing the swap, the value of A becomes 10 and the value of B becomes 5. When you print A and B, the output is 105, demonstrating the successful swap. This method is not only concise but also improves code readability and reduces the likelihood of errors. It's a great example of Python's simplicity and its emphasis on writing clear and efficient code. Global and local variables. In Python, variables are categorized as either global or local based on where they are declared and where they can be accessed. Understanding this distinction is crucial for managing variable scope and ensuring proper functionality in your programs. A global variable is declared outside of any function and is accessible throughout the entire program. For example, a variable like x global is defined at the global level and can be used anywhere in the program, including inside functions. Global variables are helpful when multiple parts of your code need to access or modify the same value. In contrast, a local variable is declared inside a function and is only accessible within that function. For instance, in the function defTest, the variable yLocal is defined within the function scope, meaning it cannot be accessed outside of it. When you call the function test, the print y statement displays the value of the local variable y, but this variable ceases to exist once the function execution is complete. In the provided example, calling test prints local because it accesses the local variable y. After the function execution, attempting to access y outside the function would result in an error since y is not defined globally. However, the global variable x remains accessible throughout, and calling print x prints global. By understanding global and local variables, you can better manage variable scope, avoid conflicts, and write more organized and maintainable code. It's also important to use global variables sparingly to prevent unintended side effects, especially in larger projects. Practice example. This program provides a simple demonstration of how to assign values to variables and swap their values using Python's elegant syntax. It highlights how Python's multiple assignment feature allows for efficient and concise code. The program begins with variable assignment where x is assigned the value 100 and y is assigned the value 200. These values represent two separate pieces of data stored in their respective variables. Variable assignment is one of the foundational concepts in programming, enabling developers to store and manipulate data. Next, the program demonstrates variable swapping using Python's powerful multiple assignment feature. The statement x, y, y, x swaps the values of x and y in a single line. This works by first evaluating the right hand side of the assignment yx, which creates a tuple of the swapped values. These values are then unpacked into the variables on the left hand side, effectively exchanging the contents. Finally, the program prints the updated values of x and y using an f string for a clear and formatted output. The result after swapping x200 y100 confirms that the values of the variables have been successfully swapped. This example showcases Python's simplicity and readability in handling variable operations, making it an excellent choice for beginners and experienced programmers alike. By practicing such fundamental concepts, you build a strong foundation for more complex programming tasks. Key takeaways. Variables are fundamental building blocks in Python, allowing you to store and manage data effectively in your programs. They act as containers that hold values which can be accessed, updated, and manipulated throughout your code. This flexibility makes variables essential for creating dynamic and interactive programs. Python's dynamically typed nature means you don't need to specify the data type of a variable when declaring it. The interpreter determines the type automatically based on the assigned value. This flexibility allows for versatile variable assignments, enabling variables to hold different types of data at different times. However, this dynamic behavior requires careful handling to avoid errors caused by unexpected data types. It's important to follow naming conventions when creating variables to make your code more readable and maintainable. Use descriptive names and follow Python standard practices such as using lowercase letters and underscores, e.g., total underscore amount. Avoid starting variable names with numbers or using reserved words like if, while, or class, as these can cause syntax errors. By understanding and applying these concepts, you can write clean, efficient, and error free Python programs. Variables not only simplify data management but also enhance the overall clarity and functionality of your code. And that's all about variables in Python. We've covered what variables are, how to assign and manage them, and the best practices for naming them. Remember, variables are the foundation of any program, so mastering their use is key to writing efficient and readable code. If you found this video helpful, don't forget to share and subscribe for more Python tutorials. Thank you for watching, and I'll see you in the next video. Keep coding and have fun with Python.